imminently. Best get warmed up, hadn't we? This is going to be a long night. And now I've discovered that actually it plays an ad for a lot of people around about now. So I'm just going to do not very much for about 30 seconds before we get started. And maybe we should look at something like a title screen for the future. I really don't know. I can see there's a discussion going on in Discord right now about it. So hello to those people in the chat already. We've got Standard Int here. Spin-off player. Channel Mouse, Alex, 10th. Oh dear. Oh well, better than 11th though, isn't it? Right, so yes, you may have noticed that this is the third episode of the CodeZone. It's gone that far, it's lasted the distance so far, and we've coded basically nothing already. But tonight, you may also have noticed that I'm starting half an hour earlier than normal. This is not to be a regular thing, still sticking to 8 o'clock on Tuesday. But exciting news, I'm having my man cave renovated as of tomorrow. So, I need to pack away all my computers and things tonight. So we're going to have an hour of show, and then I can finish half an hour early, and I can spend the next 10 hours packing all this away, I think. Hello from Cleveland. How am I doing tonight? I'm okay. I've just had a rather large amount of very spicy beef broth noodles. So I'm quite full, but satisfyingly full. Yes, good. And what I will say is I haven't really looked at the code at all since last Tuesday. There was one little change I made at the very end, which didn't actually run things to show you. So I just wanted to show that before we do any start today. And that was, I changed the formula. So you remember Ericsson came along and broke all of our mathematics. Thank you, Ericsson. And we couldn't really see what was going on with the orbiting. And we'll look at orbiting today a little bit more. So I did a quick hack just to see were things moving in synchrony or were things out of phase? What was going on? Was everything in the same phase? And all that's why it didn't look quite right. So I've changed it to this expression here just as a quick fix. And we'll have a look. And I also need to change things like the default zoom level. So if I zoom in here, but we can clearly see we've now got something orbiting something, orbiting something. So I'm pretty pleased with that. But we'll look at this maths a little bit more today. Let's keep a quick catch up with the chat. Have a sip of water. I've got to stay hydrated. Hello, Magetsa. Something went ping. I think it was a follow. Integral dxdy. Interesting. Thank you for the follow. So at the moment, we're still sort of also drawing circles and things. It's not very exciting visually. And for those, if this is your first CodeZone visit, then welcome. The whole point of this is unscripted. There is no particular plan. We get very little done. Usually there's a lot of distraction going on in the chat, and I make lots of bugs live on stream. I don't think we've got any particular interesting announcements to make. Well, nothing's popped up. Nobody's emailed me anything that they want mentioning or saying in the show. Hello, is this a gravity simulation? No, it's not going to be a gravity simulation. What this is going to be is a hacked simulation of a generic solar system with the intent of having sort of orbital paths for planets to follow. And then I can turn this into a slightly more living world. So this is a long-term project. It's something I've wanted to do for a long time. Like when I made my NES emulator, I've been putting it off. But actually, the only way I'm going to get it done is through a vehicle like this, being forced to stream it once a week. And it's also great because the chat get involved with some of the decisions that we make. Is Ericsson here yet? I don't think Ericsson is here. He's probably too ashamed after last week's disgraceful display of mathematics noobishness. Oh, it was terrible for everybody. Right, so speaking of the mathematics, so all I did was change this. This was the power function to a particular index, and it didn't work. Everything looked like it was in sync. And so, well, it probably was working, it's just everything looked like it was in sync. It was difficult to tell. So I've basically hacked it in that you just make it some linear version of the distance from the thing that it is orbiting. And that's why we can actually see the difference there. I'll run that again. Now we've got a Gorbit, Slice, and a Big Pickle. I don't understand Pog. Pogs used to be little cardboard discs when I was I was young. Used to gamble with them. That's when gambling was encouraged in schools. Nice. Yeah, Pogs were great. I had loads of Pogs. Something interesting might happen if you mix gravity and Ericsson's maths. A black hole, maybe. Yeah, definitely. I don't think there's enough. There's not enough file space on my hard drive for Ericsson's maths. Tazos, for those that don't know what a Tazo was, there's a brand of crisps in the UK called Walker's Crisps. They're called Lay's elsewhere in the world. And they had a giveaway competition where in each bag of crisps you got a little disc. It was a POG, effectively, but it had little notches in the side, and you could build these interesting and curious hexagonal structures out of these discs. Ah, thank you very much for a subscription there from A Big Pickle. Yes, I'm getting more familiar with the noises now. You're probably picking them up on the microphone, actually. What's my opinion on Raylib? I have not used Raylib. I have actually, when I first started the Pixel game engine, I was looking around to see what kind of things were out there, and Raylib was the one that kept popping up as being the nearest approximation. But I prefer to do things from the ground up. I don't need to use existing libraries all the time. I get a lot of enjoyment out of creating my own. And that's how the Pixel game engine was born. And we've got Bispoo here. Oh, hello. And can't pronounce that one, but hello. Do we still have hula hoops in the UK? Yes, we do. Right. Let's get on with some coding then. So I wanted to just sort of expand the solar system a little bit more. And I also want to draw things that we can actually see what is orbiting what. Oh. Tux Dude, thank you very much. A subscription there. Via Twitch. It says via Twitch because my notifications also tell me, and it'll probably happen tonight, maybe it won't, how many people have subscribed in YouTube. Now, the YouTube ones tend to come through in batches, which is I'm obviously grateful for, but it can get quite annoying. So if the sounds get annoying, I was told last time also that the notification noises might be a bit loud and my voice might be a bit quiet. Do shout out if we do need to adjust things. Hype train, sub, gift, or bits. I don't know what's picking. Oh, I've got some sort of Twitch achievement. Oh, interesting. Thank you for the bits, Bispoo. Yes, more taxes to deal with. Thank you very much. The subscribe notification is a bit loud. Okay, I can dial that back a little bit more. There we go. So let's do some coding. Right, I wanted to draw. This is the circle of the body, but I also wanted to draw a circle that represented the orbital path. Now I'd have to sort of get my head into gear. This is the problem with only coding things sort of for an hour once a week. It's a very mentally challenging exercise to remember where you're leaving off. So I want to draw a circle, and I want it to be centered around we ended up calling it the principle, didn't we? That was the thing that was the satellite was orbiting around. I don't think we came up with a proper name for it, but we want to draw around the principal position, and that's going to be in Cartesian space. We got that bit working, but I also want to make sure that I'm only doing this if we actually have something to orbit, or else we're going to end up getting all sorts of nasty errors. And the radius is, of course, the radius of this celestial body. So that should just be MF radius. And we'll draw that. We'll start using some colours. We'll draw that as a grey. And I want to draw that before we draw the body itself. Now, have I made a mistake there? Let's just see what happens. I need to fix this zoom as well. Right, yes, so that's drawn the wrong radius. So the radius we actually want to draw is not the radius, it's the polar, isn't it? It was polar R, so polar X there. That's what we wanted to draw instead. MV polar dot X. And this should give us then the pathway that the objects are following in the space. Yes. Very nice. Now, all of our objects are the same size at the moment. This is obviously unrealistic too. Let's have a quick look at the chats, because there's quite a few of them coming up. Why don't you use Linux? Because it's just not as good. Sorry, guys. It's just not as good. It's not as fast. It's not as simple. It's not as quick. It's not as easy. And people laugh, but Windows, it kind of does just work. And as people on the Discord server will know, all my customers use Windows, so I have very little motivation to actually use Linux. What's draw explicit decal for? Right, so draw explicit decal is a special command that allows you to draw explicit decals. So these are like decals where you've got full, complete, explicit control over the properties. You can draw them in space. It's sort of it's the back end of how the decals are drawn. It allows you to call it manually. No idea what's happening. What are you making? Well, we're going to be making some sort of, ultimately a long-term project into a game, and I'm just exploring how we can set up a solar system, and we might try rendering some planets tonight to get beyond the circles. But we certainly need to sort out the sizes of the planets. Hey Jared, I think it's an awesome idea for a video to make a project that mixes space thing with procedural generation. Yeah, so maybe. I mean, we did talk about that in one of the episodes. Should it be some massive universe that you go and explore? I tend to think those procedurally generated games, they're fun if they're not too big. Now, I'm a big Elite fan, so it sounds ironic that I'm saying that, but I like games that have had a lot more crafting put into the worlds. I find that you can make a lot more enjoyable playing experience with a small world that's got lots of stuff inside it. Right, Bispu, uncensored decals. Is this physics-based? No. So we're not using physics-based. It's purely hacked because there's literally no need for it to be physics-based. I know that there's Nanoic. I'll shout out to Nanoic. Nanoic's he's our sort of resident astronomer as well as Ericsson, and he's been interested in potentially doing something with realistic physics. We will start to look at the physics a little bit more because I do kind of want the relationships between the planets to be sensible. Right now we've hacked everything. You can see the planets are all the same size. There's literally nothing realistic going on here. Ah, thank you very much, plus Shamzone. Shamzone. Why don't people just pick names you can say easily? Right, missing a tween on Zoom. Yeah, I don't have an explicit zoom. There's reasons for that actually, but I'm not going to go into those this video. My zoom is currently powers of 2 each time. Actually, I could probably put the tween on this whilst we're drawing it in vector mode. Actually, you know what? I could actually just do it anyway. There's literally no reason why, because we're not doing anything tile based. Now let's do that. Okay, so first community suggestion is, should we make the zoom a little bit smoother? So my zoom is currently like really quite aggressively chunky at the moment. So if I change that to 0.99, I guess, and change that to 1.01, is that going to work? Maybe it'll be too slow. Let's have a look. Let's pull that over. Scrolling. Come on. Right, so we need it to be a bit faster than this. It's no longer practical. But there you go. So that's a nice, smooth, continuous zoom now. So we could play with that. So, I'll just try and improve all of that by a factor of 10. Let's go to that. Just see if that makes it a little bit easier to use. The other reason for going with the power of 2 is you go back to levels you've been to before. Floating point numbers are very good with multiplications by 2 and divisions by 2. Of course. So it's actually, you can go back to a zoom level you've had before. I could do the same with discrete steps. I'm going to leave it as powers of 2 for now. So, oh, here we go. So are these the YouTube ones coming through? There's a few. Oh no, just regular Twitch files. Thank you very much, guys. It's much appreciated. Could I give some advice on how to write more readable code? You're asking me this question. The one criticism I get more than anything else is that my code is barely readable. It's barely C++. And can I give you any style advice for it? I would suggest if you see what I'm doing, do the opposite is probably the most sensible advice I can give. Yes, I'm a big fan of Hungarian notation. No, you see straight up there. First step, don't use Hungarian notation. That's just not true. Hungarian notation is what the winners use. Yeah, us winners, we use Hungarian notation. Right, I also want to draw a little line that goes from the principal to the current planet as well, because I think later on we might be able to reuse these as sort of navigational aids for our universe. So I'm going to draw a line. Now, you may be thinking, how's all the scaling and everything being worked? That's because we're using a transformed view, which is an extension to the Pixel game engine, which allows you to draw things scaled. And we may find some bugs with that later on live, and that'll be quite exciting. So we're going to draw from the same place as we had before. Potentially could cache that, but yeah, leave it for now. And I want to draw to my current Cartesian location. Get Cartesian. We'll pick a colour. Let's do that as OLC green. And we'll also specify a nice pattern for that. We'll have F0, 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 F0. So that's going to be a dotted line. Let's try that. So as you can see on the streams, things go a lot slower than the YouTube videos. It's far more laid back. It's just messing around. So that should have drawn. Yeah, there we go. So now we can start to see some dotted lines. The grey's a bit bright, so it's difficult to identify what a planet is relative to what the orbital ring is. I can't do dashed circles sort of natively in the Pixel game engine. I can do segmented circles, but I can't do dashed ones. I have no doubt that before the end of this video, the community will have submitted something to be included to draw dashed circles. It's not like being able to copy out the code makes you code slower. Well, it's not. Yeah, I think what makes me code slower is the chat, but I quite enjoy that. That's what this is all about. It's meant to be relaxed. It's meant to be a bit more silly. So we've got a single orbiting body of our Earth. Now our framework should make that quite easily to add additional orbiting bodies. In fact, we've got them up here, and we've been creating them as discrete variables at the moment. So we'll stick with that for the time being, just whilst we're building up some debugging. But later on, we'll actually want to change this to a different structure. So this we have Moon, let's call this Moon 1 and Moon 2. So Moon 1 is our existing moon. And Moon 2 is, of course, the other moon that the shady government corporations don't want you to know about. That's where all of the sort of the secret weapons are kept. And we'll also make that one orbit Earth. We'll give it, what was the body? That was the distance of the thing, wasn't it? So that was 5. We'll send that, because the radius is a 1. We'll probably have to start changing the radiuses. But what I want to do is attach 2 bodies to one Earth. Oh. Crash. Oh, because I've now, yeah, no, that was it. Yes, I changed it down here, didn't I? What I need, right, I'm thinking of getting one of those, actually I was thinking of writing, because in the past, maybe 2 years ago now, I've written some Pixel game engine to Twitch interaction tools. And we had some fun where the chat could type things in, and they controlled a robot, and they've controlled some in-game stuff and things like that. I was thinking of having something where when I create a bug or a syntax error or something like that, you could all spam the chat with a special command. And it makes things fly across the screen. I thought that might be a bit silly. So maybe that'd be our first branch of distraction, would be coding that up. But still, where have I got? I've missed another moon down here. This is why you want these to be in some more intelligent data structure than just listing them all discreetly. Hello from France. Hello from the UK. Right, I need to set this default zoom. I know I keep saying it. Right, there we go. So now we've got 2 bodies. They're orbiting at the same speed, which is probably not... well, no, they're not actually orbiting at the same speed, are they? One is... No, they are orbiting at the same speed. It's too complicated. You can tell it's been a long day. And my cough is not entirely gone. It's much better than it was last week. Right, so we know that we can add in planets. I think it's time to start dealing with the radius of the planet, which currently we don't specify. We specify the distance, but we don't specify the size of the planet. And part of the reason for that was I was unsure, do I want the celestial body base class to be, well, a base class, or should it become something more intelligent than that? And we actually have like a dedicated moon class and a dedicated earth class, but we'll see what happens. This is how I like to write code. It's a bit of an organic thing. We'll try some things. If it doesn't work, we'll change it, move things around. Gergo Pronai. Pronai, thank you very much for the subscription. I know you've been here quite a few times now on the CodeZone, and I've seen you on the server. It's always good to see new faces that come and chat and stick around as well. That's a good thing. Ah, good. It's good to see there's people in the chat already discussing code there. Yes, that name read. So the name reads are the hardest part. Yeah, if anybody was expecting everything to be all in one file, by the end of it, I'm actually expecting this to be quite a complicated project. If it goes sort of the direction I want it to be, and I sensibly need to have that separated into different files. But it's also good for those, because I don't often show it on the YouTube channel, that you can easily create multi-file projects using the Pixel Game Engine. All you do is the way I do it, is create a CPP file called OLC Pixel Game Engine. Where's that popped up? That's popped up over here. Ugh. See, this is all the stuff I can edit out. In that CPP file, I simply include the Pixel Game Engine, and I also like to include the extensions that I'm using as well, along with the define keywords, and that's it. You just use the Pixel Game Engine wherever you want, normally in your file, in your folders, in your files, and it just all works. It's just all magic like that. It's all down to the C++ preprocessor. It's a real magical thing. Completely lost track of what I was doing. I was going to do celestial body and add some sort of radius parameter. Now, I think we did, didn't we? Oh, no, we added distance. Did we not add a way of setting radius? We didn't. So let's add in a way of setting the radius. Well, just simply add it in as a parameter to the constructor, I think. Radius, and we won't have a default radius of 0. We'll have a default radius of 1. Now, these values at the moment are fairly made up. Now, it may be that when we start adding a bit more maths to how they interact with each other, we need more realistic numbers. In my prototype for this, and my prototype is really just the rendering side of things, I did put in real numbers, actual scale numbers for the sizes of things in the solar system. And it really made for quite a boring experience, because, as I think I've said it in the last episode, space is really empty. There's not much in it. And you could easily lose the planets, and that's why I think having navigation aids and lots of other things in the solar system is better than just having it randomly create actual size solar systems. It's not very interesting. So I've added the radius parameter to my constructor. What I'll need to add now to my celestial body class is the, yes, I need to add that in here. See, it's already complaining out saying I haven't done that. Float radius. I've also noticed rather cheekily whilst I'm here that my F distance, so that went in as F distance. Did I not call this F radius? Is that not what I call it? Why did I not use Hungarian notation? Why am I confusing myself? What's just going on? Yeah, I want to try and stick to some sort of consistency. So yes, I didn't. I just called it radius. Ugh. Ugh. How do I know if it's a float or not? Right, so go back to the celestial body, and we can set the, we have a member variable called radius, which is not the same as the radius in our polar coordinate. That's the distance to what is called the principal. So our radius is going to be radius. There we go. So now once we've got that radius, we can start adding things into our, when we're constructing things, that's it. Where we're constructing the planets, the solar system itself. I don't like coding with two windows that I have to keep sliding around like this. I'm finding that quite distracting. But it's a bit quicker and easier than having multiple windows open at the same time. I think what I'll do is I'll put the celestial body, don't crash. I'll put the celestial body class over there, and the Pixel Game Engine and main game class over here. Maybe do some dimensional scaling, decrease distances and increase time elapse. Well, these are all the weird things, exactly. So what right now, obviously our planets are not going to be moving that quick around each other. I mean, 1 year is currently about 1 minute in our system. But what's a fun rate to play at? We'll have to do all this sort of balancing as we make the world more sophisticated. But right now, let's add in some stats. In fact, should we have a go at adding in sort of semi-realistic stats, or maybe not? So if we say that our sun, for example, now we set a distance there to fake that. Oh, that was the Earth. So the sun is up here. So the sun has no parent, and it has no distance. But let's give it a radius. Now this is going to break things straight away. A radius of 100. Thank you for the follows. If I don't shout out, I do actually see them. I'm still sort of new at this Twitch game. They do pop up, and I do see the names popping up. So I appreciate that. Thank you very much. What's the advantage of the smart pointers? Well, it makes me look like I know what I'm doing with Modern C, right? Just make everything shared. No, that's not true. Thank you very much, TFL6502, with your Twitch subscription there. Thank you, appreciate that. The idea of a smart pointer basically is ownership, right? And that makes it quite distinct. People just say, oh, it's so you don't get memory leaks. Well, that's part of the story. The reality is it's about ownership and who owns memory which is allocated. Now, at the moment, it seems a bit daft that I'm using smart pointers because there's nothing particularly sophisticated. My planets here are owned by, well, the whole application. I could just declare them explicitly, but I want to put these into... firstly, I need them in pointer form because I'm planning on doing some polymorphism with them later on, which I need the pointers in order to do that. But the other reason being is I do intend to create a sort of solar system class, and the moons of an object are owned by that object. I think that's a nicer data structure to have. So if I removed the Earth, for example, then it removes all of the moons attached to the Earth. And so smart pointers allow me to do that without having to worry about sort of that parent-child relationship manually. As Morris has just said all that, I should read the chats before I actually say things. What are we using for orbit calculation? At the moment, it's a disgusting hack. But we will improve that, because what we're going to see right now, actually, just the perfect time to ask that question, is as I'm adding in these radiuses, these fake radiuses, the system's going to collapse and crash and stop working. So we'll just keep doing that anyway. Now, I'm setting my sun to 100. So I'm going to set the distance of the Earth to the sun to be... for now, 500, right? So I know there's nothing like realistic at all. But I'm going to set the radius of the Earth equivalent to be 10, and we'll set the 2 moons that we've given our Earth. We'll give those a radius of 1. We'll give a radius of 2, so it's pretty big. And we'll say that you're about has to be more than 10. So let's say. We'll set you at 20, and we'll have another moon, a small one this time. And we'll set you at 30. Now, I'm going to run this, and it's not going to work, and we'll see why. In fact, it's going to look quite strange because of the orbital mass that's just popped up. To make things so we could tell if they work, I've hacked in this thing. It's got magic numbers in it, it's got constants and all sorts, and that's going to actually stop any of this from making sense. So let's just see if it builds to begin with. It's a good start, isn't it? Yep, so there we go. So it just all sort of goes, blah, blah, no idea what's going on. Although it's pretty. It's pretty. If Lubitech was watching that, he'd be going, yep, that's just awesome. So there we go. So that's our solar system accurately simulated there. So I think we do need to make things just a little bit more accurate. Now, I in my prototype, I tried to do this, and we can debate this as a community whether this is the right way to do things. So my celestial body, the only information I've given to my planets during the construction are the radius. Now, I'm going to assume all of my planets are the same density. So, tell me it's radii is the plural of radiuses, or it's the plural of radius. So I'm going to assume all of my planets are the same density. I'm not a physicist in this regard. But I do recall, and I will pull in the... I've got the maths in my little prototype up there. So if we wanted to create the volume of the planet, we could then calculate the mass. But I guess do we even need to bother calculating the volume, because all we need is a number that represents some sort of relationship to the mass. In which case, the speed, and I've got here a magic number again, so we'll have a look at that, so let's see what that is. So what is our speed? So we can calculate our angular velocity. Okay, I'm going to pull this code in, and we'll discuss it and see what it does, because I'm sure there are people in the chat that actually understand what's going on here. So let's pull that in. So let's copy you, and we'll whack you in there, and we'll have a look at what's going on. because we'll need to refactor it a bit. Firstly, we have principle. So it looks like in my prototype, if I have a principle, then I want to get the mass of that principle. And there's a magic number there. I'm sure somebody can point out what that constant actually is. So let's just get this. So double m. We'll not use doubles. We're using floats, aren't we? So float. Oh dear. See, that would be cool that we could spam the chat with something and it all breaks the screen and whatnot. Well, I might think about that for next week. mf primary mass equals. I'm going to set. Oh dear. I'm going to set that to just 1 for the time being, just so we make sure that none of our maths completely falls apart. Right. If we have, I've called it primary again, haven't I? Why did we not stick with primary? Who was it that said principal? Yeah. Make sure that I silence you on the Discord server. So if we have a principle, so if it has like something that it's orbiting around, we're going to, and I'm not going to say get mass. Well, and maybe I do need to have get mass, don't I? Because yes, I do need to have a get mass thing. We'll need to add that in. Okay, so let's add in float mf mass to our celestial body, and we'll just give that a default value of 1. And we'll add in float get mass. And I'll wait for that to go green squiggly, and I'll right click on it. Quick, because this is how lazy I've become. This is the problem. This is what IDEs do to you. I can click on that and I can go return mf mass. There we go. So we can now get to the mass of our principal, not our primary. Good. So now I want to work out what the speed is. So this is, I believe, the linear speed. And so somebody thrown in the chat what this constant actually is. I can't remember what this constant actually is. Nobody's thrown it out there yet. Ah, there we go. Oh, is that the gravitational constant? Yes, see, somebody clocked it. Right, so if we take the principal mass, excuse me, and there's our distance. That's our distance to the primary. It's our radial distance, and our radial distance we've actually got here as being our polar coordinate x, or in this simple instance is just f distance, which is one of the arguments that we passed in with the constructor. So I can get out of that a speed. Now, next couple of lines. We wanted to turn that speed into an angular velocity. Well, that's just the speed divided by 2 pi. 2 pi, what was it? 2 pi d, yes. If we don't have a radial distance, I guess that's the same as not having a principle, isn't it? My prototype doesn't reflect the same structure that we've got here, so that's why I'm sort of coding things on the hoof a little bit. We do need an angular velocity variable, though, so let's add that in. So float mf angular velocity. So this is the rate at which the body orbits the principal. I'll set that at 0, because things like the sun don't necessarily orbit anything. They're not going to move. The radial distance, as we've just discussed, is the same as the f distance. Now, can that f distance be... It can be, can't it? F distance can be 0, so that's going to cause a problem. So if we are the sun... it looks like yes. So this speed is a temporary calculation for later on. So that's okay. We're not doing it. We can do a divide by 0. It's in float. It'll just collapse anyway. We could tidy. Well, in fact, you know what? We will. We'll tidy this up a little bit because I don't think we need this speed anywhere else. No. Okay. So let's. If we have a radial distance, which is now f distance. If our f distance is 0, then the angular velocity is also going to be 0. However, if we have a distance of 0 here, what that means is we are the center of the universe. We're not orbiting anything at all. So we don't have some sort of orbital speed. I'm going to be using all the wrong terms here. This is where people complain on the YouTube. Oh, what's this numpty doing about space physics? He doesn't know the first thing. Correct is my answer to that. And what we'll do is we'll stick this down in here. There we go. And now we can calculate our angular velocity. by looking at our speed, by converting our, I think, our linear speed into the angular speed. Yes, that's f distance. And we know that in this instance, f distance is not going to be 0. We've explicitly checked for that. We could do a floating point check, but hey, the only time this is going to happen is when these things are going to be constructed, and I'd be surprised if the construction passing in 0 for f distance or f radius in this instance will actually yield some sort of error. I don't think that'll be the case at all. Right, I'm going to have a quick catch up with the chat and a slurp of water because there's all sorts of things going on. Morris, that's why I asked the question. I don't know what's going on there. You can have a shared pointer to something on the stack. Look, yes, you can. You can, but it's not pretty, right? I remember a video where Javid said he doesn't like smart pointers because he likes to be in control of memory. No, I still do believe that that's the case, and you see people will see me type on the Discord fairly frequently. Don't leave the smarts to the pointer. Really, you should be thinking about the lifetime of your objects rather than just thinking, oh, well, it's an object, it exists, and I don't care. Really, you know, as a good designer, you should be thinking, I'm adding this to my program. It has a beginning, it has a middle, and it has an end. And you should have a case and a scenario and a thought process for all 3 stages of that object. I'm using smart pointers in this case because I'm hoping that this data structure that represents our solar system will become more sophisticated as time goes on. And as Morris says there, yeah, you know what, it sets a good example and silences the pedants as well. We all like the pedants on here. Custom allocators are definitely one of the well-supported use cases. Yeah, we're getting into sort of extreme weird territories, though. I mean, that's the beautiful thing about C++, is I've found that on the whole, and you know, I've made a career out of doing C++, and I don't starve, so I'm doing all right, I think. And one of the things I've noticed is actually I use maybe 10% of its capabilities, and that's professionally on large code bases. I've worked on big projects, I work on complicated projects, I work on projects, split them across multiple companies. I still find myself that I'm using 10% of the features of this language. And that's one of the reasons I think it's so great. You get to sort of express yourself. So if you're sat there and you want to have a complete nerd out exercise and really try and optimize a way of writing the code, you can really delve in there and use all of the features, but you don't have to. And I think that's quite an important thing. You don't have to. And that's what I believe makes C++ great for beginners. I think it's a great beginner language. It surprises me when people say, oh no, it's too hard for beginners. Well, you know, it wasn't too hard when we were back in the 80s and we didn't even have the internet to tell us what was going on. But hey, that's a row for a different episode. Sorry, Morris. Why do I want to do heap allocation over stack allocation? Oh, you got an answer for it. Yeah, I thought I did answer that. Yeah, I've got some floating points here, which are not actually floating points. They're actually doubles. But hey, you know what? I'm going to leave that for now. We need to push on and move on with what we're doing here. So we've got an angular velocity. And what I'm going to use is that angular velocity to specify how fast our system moves around its principal. And that's just a case of changing the y component of our polar coordinate because that is the angle. So I should just be able to say that is now mf angular velocity. Now I'm still going to modulate it with elapsed time because there's a frame rate, it's still there. But we may need some sort of global scaling coefficient to make the universe actually operate at a sensible speed. C++ is the ugliest language I have to work with, but of course it's made to get work done. Exactly, it's a great language for making work, for getting things done. I will point out, I didn't actually learn C++ in the 80s. I started using C++ in anger and sort of primarily using it all the time about, probably about 1999. I dabbled with it a little bit beforehand. I went to night school as a teenager to go and do the programming classes at night because they were basically free exams I could take and I had nothing better to do because I'm not that exciting. So I went to these night school things and the courses they had on there were C++, so I did that. I did Pascal. I did Visual Basic. Oddly, I actually got quite far in the Visual Basic stuff. And it was Turbo Pascal back then, but it was Turbo Pascal in a Windows environment, but it wasn't Delphi. It was some sort of Borland Pascal variant that ran in Windows. I think it was Windows 3.1 as well. They were just very exciting times. Good. Well, I'm glad that there's a mixed opinion on C++. Yes, it's not perfect by any means, and I think like anything which is worth pursuing, it isn't complete, and that's the beauty of it. I do worry about the future of the language a little bit. I worry that it's becoming a little bit, in a non-controversial way. It's becoming a bit Me Too, that it sees features that people like in other languages and goes, hey, do you know what? I've got to have that too. And I'm hoping that that's a phase, but we'll see. We'll see. Right, so where are we? Because I've lost track of completely what's going on. No idea. Right, so, well, we've got the sun. That's very good. And we've got our planet Earth somewhere. I think. Maybe. And our radiuses for the planets are clearly not right. So, well, they even look like they're not quite central either. So I've got some things a bit wrong there. Radiuses aren't quite right. And, of course, nothing is moving. Well, let's start debugging what's going on. Sorry, have we just dropped a handful of frames? It doesn't look like we've dropped a handful of frames, but I saw the Twitch pops up with a little warning to say things are not going well. So do let me know if there's a problem. Right, so we saw nothing kind of happen. Well, we've got debugging tools at our disposal. Let's have a look through them. I think to begin with, we'll start cutting out a few of the bits that we don't need. Because I've made this multiple window thing. That makes things difficult, doesn't it? Right, so we'll create the sun and we'll create the earth. And we'll start just with those. Now, so I'm going to get rid of my moons. Because if we can make it work properly for the earth, we can probably make it work very well for the moons too. Now, so if I run that, we should just see the sun and the earth. Oh, see, that's interesting. Why have we already got a crash? What's going on? Oh. Did I accidentally click a breakpoint in the way? I think I did. Yes. Right, so we can see... do you know what? I need to colour these things a bit differently because I think that's part of the problem. I couldn't see which was the orbital path and which was our actual planet. So I'm going to colour our planet slightly different colours, just so I can tell that it's there. Celestial body, that one. So when it's drawing itself right now, I'm going to choose to draw the orbital path as dark grey. So it's less visible. Ooh. And the principle that the line that can, I mean, the line could stay where it is really, but we'll change that to dark green. But we'll change this cyan to something that's like really quite vibrant for now. Because I think the magenta is just, so the cyan's just a little bit too close to the white. Right, that's a bit better. I can see what's going on now. So we've got sun there, and we've got the Earth, and the nice thing is that the radii of the planet seems to be about 10 times smaller than that of the sun. Okay, good. Is the source code available on... Sorry, I just saw that one above it. We can't find Earth, we are lost. Is the source code available on GitHub? No, not yet, because there's not really any source code to put there just yet. If there's enough interest, I might consider putting it up. One of the things I don't want to happen, though, is if I put it up on GitHub, then before the end of the week, I've had 5 or 6 pull requests with people wanting to add features and stuff like that, and then I've got to say to them, well, thanks for your hard work, but I'm not including them because I'm trying to make a weekly thing out of it. It becomes a problem when people actually look at your GitHub repos and want to take part. I'm really grateful for it, but at the same time, it can sort of really interfere with getting work done. So I want to work out why my Earth is not moving. Why is my Earth not moving? So that's got to be something to do with our angular velocity not being calculated properly. Or, indeed, because we've used realistic coefficients. It's just it's very, very small. So let's actually debug this and see what's going on. So come to the constructor of the celestial body. And I believe the first constructor should give us a principal that's empty. So this is the sun. So the sun, as we step through, should have an angular velocity of 0, and it does. So the next one should be Earth. So this is Earth. It says here our principal is difficult to see now because we're using smart pointers. See, smart pointers are not that smart. Maybe I should have put a string in so we could name these, but we can see that I know that this one's going to be the Earth. So the distance there was 500, the radius is going to be 10. So the mass of our sun, so that might be the first thing, is that the mass calculation is just currently 1. So that's probably no good. And are we using mass in any of these calculations? Yeah, we do actually use mass there, so we probably do want to sort that one out. And the distance is not 0, but our speed. So the speed is a really small number, and our angular velocity is an even smaller number. So that's simply the case. So it's because our universal scales are not realistic, right? So things don't behave as they should do. So we want to set our mass to be something a little bit more sensible. And I think for that, all I did was set it to be the volume of the sphere. I assumed the density was constant across all of the planets. So we just have this sort of universal uniform density. But I had the mass related to the radius. Now, sure, can you all remember what the volume of a sphere is? It's one of those odd ones that I can always remember for some reason. Is 4 over 3 times pi times the radius cubed, wasn't it? Times f radius times f radius times f radius. Now, of course, even setting this as being somewhat quasi-accurate in terms of the physics, we're still nowhere near, because we know that the radius of the sun is not 100 relative to the radius of the Earth. So do we start to spend effort and time in putting in realistic numbers, or do we just hack things to try and make things work? So we've now got some mass, so do we get any kind of movement at all? Let's have a look. We probably are. It's just it's so infinitesimally small, we can't see it. Maybe we should display on the screen some of these numbers, and we can actually work out if anything's changing. Or we can do the do things the one-line code away and whack a great big constant into the equation and see if that makes any difference. I think we might need a slightly bigger constant. We're going to run out of numbers. Yep, so you can see it. It is moving. It is moving. I promise you, it's moving. You can see it there. Let's go on. Let's try this. It's not going to. The maths is going to fall apart here, because we've got a very small number here times this very large number here. So we may actually see things just start to collapse and fall out of being common sense. Right, there we go. Very slowly, it's beginning to move. But this is the problem, right? With choosing realistic physics. Suddenly, you need the rest of the system to be realistic as well. So Ericsson is here, everybody. You are using the real gravity constant when all the other values are fake. Exactly, that's what we're just describing, right? So it's it becomes, what's the point in using the real gravity constant? And I think you're quite right. We may as well just set that to 1 or something like that. Just set it to 1. And then we can start working with slightly more sensible values and scaling coefficients. So let's set that to 1, and we probably may end up in a situation where we have to start slowing things down again. Oh, Ericsson, have you broken my maths again? You've dropped into the chat sort of 10 minutes before the end, and you've broken the maths. Now, we can see this time, without the big scaling coefficient, we are actually seeing movement there. So it is actually happening. If we go even further, let's set that to 0.01. Have I gone the wrong way there? Should that have been... Yeah, I've gone the wrong way there. I think that should have been... we set that to 100. Yes, because we want the speed to get larger. It's getting there. It's getting there. Let's set that to 10,000. I want to see this sort of spin around. Okay, well, it's moving. It's moving at least, so that's a good start. It's not very exciting, though. That's the problem with space. Space isn't very exciting. Davey 40k, hello. TikTok, TikTok from Alex there. Should I use numeric limits float max? Somebody had a bug with that on the Discord the other day. Had an interesting result that they were truncating the maximum double constant to an integer, and it wasn't giving them the results they expected, and for obvious reasons. But at first, it did take quite a few people to have a glance at it before a solution appeared. Right, so let's add in our moon again now and sort of see what's going on there, because something's not quite right with... Where am I going? Because I'm wondering, I double click on these things and they pop up, but they've already popped up, so they don't need to pop up again, which is no good for me. The radius that we're setting our moon at for that one, I think that was part of the problem. So that was set at 500. There's literally no point in setting it at 2 from there. Let's set that at... Yeah, so that was part of the problem as well. I think I got the radius and the distance mixed up. So the distance of the sun is 0, the radius is 100, so there's distance there. So that should be a distance of 20, and that should be a radius of 2. So that was our first mistake. Okay, well that's quite nice. Did we come to a consensus last week that are there any known moons that have moons? I'll leave that one for the chat for people to figure out, because I mean our engine would support that. Now, one of the things I'm also noticing is that as I zoom in, like really close, the frame rate is starting to tank. And that's because it's still drawing this huge circle. And at this scale, that huge circle will be billions of pixels. So that might be something we want to adjust later on. And we'll get it to draw sort of only the bits of circle that it can see. We'll need to think about the maths behind that a little bit. But that might be a fun addition. I know there's a regular in the chats, Alter Ego, who's thinking about how do we draw arcs and things successfully in the Pixel game engine and more easily than we can do already. Let's go and add in our second moon then, and we probably had the same problem as before. That's why it looked a bit silly before. We had these all the wrong way around, didn't we? So I'm going to set that as a distance of 30. Oops, something went ping. Bispoo, thank you for the 100 bits there. And we'll set the radius of that one to be quite small. So that's a very small moon. We'll set that to 0.5. Moon 2. Moon 2. Let's have a look. Cameron the introvert. So there we go, we've got our 2 moons. And the speed at which they're orbiting the bodies is related to the size of the planets and the distance from the thing they're orbiting. So if we set this small moon here to be actually very far away, in principle it should orbit a lot slower, and that should just drop out of the maths. So if I set this, instead of being 30, let's say I set that to be 130, so that's really far. Let's have a look. So yes, so this time it's orbiting far slower. So the nice thing is now we've put in this sort of pseudo physics into our universe, but it's actually making things behave in a semi-realistic way. That's probably good enough for our game. Excuse me. The stream is choppy. I don't think it's a... There's no record of any problems that have been here. Not dropped any frames. Have we come to a conclusion on whether moons can have moons? No, there's no discovered submoons discovered as of today. That's really disappointing, isn't it? Wouldn't it be really cool if there were like... What if there were sort of planets orbiting suns and the moons are orbiting the planets, but then there's moons orbiting the moons, and the full path that they're tracing out is like one of these fast Fourier transform plotting tools, and they're actually drawing out these fantastic patterns in the universe somewhere. But it's a shame that we've just got boring old moons and planets. Stupid universe. It should have tried harder. Right. Well, I mean, we can have moons of moons. That's okay in our system. And maybe that'll be an interesting way of having things like satellites that actually orbit the bodies of the planets. So you know what, we should try it. Stand by the things that we say. Let's bang in a satellite for Moon 2. Make it very small. So Moon 2, we'll have this as our first satellite. Satellite 1, in case we have a few more of them. And satellite 1, we may get hit with a frame rate issue if we keep zooming in things like this. Satellite 1 is a new celestial body. It's going to not orbit, that's going to orbit Moon 2, MP Moon 2. The distance from Moon 2 is going to be very close. So it's going to be 0.8 this time. And the size is going to be very, very small because it's a satellite. Now, obviously, this is where we need to start thinking a bit more seriously about the scales of things in the game. And, of course, we'll need to update the satellite's position in space. I think I said at the end of last week's episode that we would tidy up sort of how we're representing the universe, and we haven't done that today. Instead, we've been tidying up this maths. But I think this has been an important step because now we can literally just throw additional things into the universe, and it just should work. We'll also need to look at, perhaps in the next episode, or maybe we can do it this episode if we can draw it or represent it. The planets will obviously rotate in place as well. You know, we have day-night cycle here on Earth, so we'll need to look at what the sort of the frequency rotation of a particular body is. Right, so we added a satellite to our moon. I've got to keep up with this now as it's moving around because we zoom in so that you can see the mass of our satellite is potentially far too big for our universal simulation. And this is where we're going to start to need hacking factors to make things sort of feel sensible and fun to play. Right now, everything is probably happening a bit too quick anyway. But if the game, for some reason, required that you went from this planet to the planet on the other side here, and you wanted it to take an hour for that journey, is this a realistic speed? In which case, is this just far too fast? That's why I prefer having sort of handcrafted universes, that we can actually get the solar system to tell a story just through its creation, because that's too fast right now to be playable. Another way to look at this is we could distort temporal physics depending on proximity to objects. I'm sure that'll get Ericsson very excited. But we can leave that for now. But at least our engine will allow us to have satellites orbiting. Maybe I should also add a feature to lock on to a feature so I can follow it, because that one's just moving far too quickly for me to follow. Right, so I think what I'll do next is... I'm reluctant to draw these as filled circles. I'm wondering, should we cull them? Should we wait? Because I've only got a couple of minutes left before the end of tonight's show. So I don't think we'll add another feature just yet. But I'm quite pleased with how that has come together. Oh, hang on. I've missed quite a lot of chats here. In huge gravity fields like Saturn or Jupiter, it's unlikely to be a stable system. Yeah, I guess they probably can't naturally form. There's always something that's got to win, right? We've not had any Uranus jokes on the stream yet. It's just disappointing. Guys are just not trying hard enough. Yes, camera locking function, I agree, because it's getting a little bit tiresome trying to manually follow these things around. How did you think I would get excited about things that break physics? Touche, Ericsson, touche. This is why you're probably one of the smartest guys on the planet. I like that. Or a notion like the friendship drive of Elite. What is it? What is it in Elite? In Elite Dangerous, it's Wicker space or something, isn't it? The Witcher space that you fly through in between. Also, I'll take a little poll whilst I'm here. Do people want me to put this on GitHub for some reason? I mean, I really don't mind. I mean, it's going to be sloppy and it's not going to be sort of finished off, and it probably will contain bugs, and it won't be updated between videos. Yeah, okay. I know a few people have asked for it. So I think I will. Right, well, that's probably a nice enough place for today to stop. We should be back to normal next weekend. Next week. I'm a bit earlier this week because I'm having renovations done in here as of tomorrow, and I need to start demolishing all of my man cave, tearing it down. It's the first time the computer will have been switched off in 7 years, so a little bit worried about that. I'm getting new Windows installed, not the operating system, the actual physical Windows in my house. They're all being replaced. Will orbits in this engine always be rounded? Yes, probably. Simply because it's not meant to be an accurate model of the solar system. It's meant to be a nice quick hack for a game world where I'd like the spaceship to be able to travel from planet to planet nice and smoothly, and you can perform trades. And I'd like to have maybe some multiplayer thrown in, maybe some AI, and it becomes just a nice platform to start experimenting with other ideas, sort of like slightly larger ideas that we don't necessarily get to cover on the channel. One of the things this year I'm avoiding are large series on the YouTube channel. We did that a lot over the last sort of 18 months to 2 years. Everything was always a big thing. It's always a bit. We had the NES emulator, and that's very time consuming. It's very tiring to put that sort of thing together. So this year is a lot more about little one-offs. One-off videos about small bits of technology. As soon as we finish the MMO series, I've got the rest of the year planned out in terms of videos, and they're all sort of one-offs, useful tidbits, interesting algorithms, the sort of standard one-lone coder stuff. But by doing that, it gives me a lot of free time to start working on projects such as this. Oh, we should do one thing before we finish it off. I want to sort of just double check. Does this all now still work in the Inscripton build? And that's because the next video is going to be the Inscripton version of the Pixel game engine. Now, I know many of you have seen what this is, but it was created by the guys, quite a few, I think a couple of them are in the chat now. We've got Morris, Gorbit, Dandestein, Magetsub, Slavka, and even Saladin and Bispu. They quite a few people have been involved in the construction of this. Slice, Dragoneye, over the years, and it's a way to compile these things for the browser. Now, I can't even remember my own tools here, but I'll be launching this sort of next weekend, along with a video of how to set up Inscripton, how to use the tool, how to actually build it. And I'm hoping, and I'd like to get some feedback. Could you let me know if you guys are interested? I'd like to do a specific Pixel game engine, web browser-based Pixel game engine jam. That's all that's allowed. So we don't know what the theme's going to be, but you're only allowed to use the web-based version of the Pixel game engine. How interested would people be in something like that? So I've compiled that, so I'm just going to try running it and seeing if it works. Oh, there we go. Good. So I'm just going to bring that over. So all you saw me there, all I've done is compile and run the application, and you can see it's now running in the web browser. It's exactly the same. There's a few little gremlins we do need to work out. So things like the scaling here, you can see it doesn't look quite as nice. That's because the window size is causing little aliasing artifacts like that. I'm talking to the guys about sorting things like that out, but as you can see, it's compile and go, and it's now web-based, and you can upload this applet or application directly to itch or something like that, and you can have your game there, and it works just exactly the same as your desktop version. I've completely lost the Twitch chat. There we go. Where can you find WebPGE? WebPGE will be released at the weekend, hopefully. If my man cave is put back together, everything relies on the fact that I actually have a window. Because if I don't have a window, we've got storms coming in for the rest of the week. Yeah, so it's just, excuse me. You go out and Anycator. It is straightforward to do this once it's set up. I just click on those two options, but the setting up process requires a bit of an install and that sort of thing. Yeah, so Morris did a lot of the sort of web front end for this, and getting the Pixel game engine to look and feel sensible in the web environment. And he's the guy that I need to look at. Why is it squashing? I think it's just squashing it by 1 pixel in the y-axis, but it seems to do it on all of the demonstrations, and that's why they're just looking a little bit blurry. Right, well, with that, I'm going to say good night to you all. Thank you very much. A lot of follows today, and a lot of subscribers too. I don't think I've ever had this many Twitch subscribers before, so that's going to be interesting to see what actually happens. I don't think Twitch has ever paid out. So maybe that'll make something happen. But thank you very much for the follow. I'll be back again next week with another live dose of silliness. May have some interesting news next week as well. I think some people on the Discord already know, but I'm going to be maybe guest talking on a particularly popular C++ podcast. So I'll let you know if that pans out. I don't know. They may not want me or not, but we're sort of starting to talk about it. And in the meantime, I guess take care. I don't have anyone to pass people on to. So have a good weekend if I don't see you before, and I'll be making a video at the weekend. So yes, I'm going to click the stop streaming button and have a good night. I'll be chatting on the Discord, by the way, so take care.